Hey YouTube, what up, what up? So we actually keep going our algebra, and so we're on the topic linear inequalities right now. This sort of continuation of linear equations, however the sign is a bit different. Alright, so remember about equations. So we agreed to connect two expressions, algebraic expressions containing some variable, probably in both parts, with equality sign. That's how we define equation. So in contrast, if we have, instead of this equality sign, expression 1 might be less or equal, or might be just less, or might be more or equal, expression 2. So in this case, we have to deal with linear inequality. So each expression should be linear, or at least like one is linear and another is just constant. So in this case, we'll have linear inequalities. So best example to demonstrate that, you probably noticed driving a car, or probably just going by car on the road, you notice the sign that tells you about speed limitations, let's say 30 miles per hour. So what it tells you guys, it tells you that your speed, in this case variable v, velocity or speed, is not supposed to exceed 30 miles per hour. That's simply a simple inequality. We have a variable here, and we have limitation or limited number that actually your variable is not supposed to exceed. So that's typical application in real life. Also, probably for patients, I don't know, in hospital or somewhere else, so probably pressure regime might be restricted with variables also. And for example, temperature, due to specific conditions where need to conserve our food. For example, somewhere in the freezer, so we agreed to have -5 Celsius and up to, let's say, -1 Celsius degrees. So we need to keep up temperature in between. So actually it will be expressed through inequality from -5 and up to -1. So if we include those boundaries. Alright, as you can see, inequalities is real, have real application in life. So actually this topic is must to know. Alright, so let's consider simple inequalities. Represent the following inequalities on a number line. So why a number line, you ask me? Because it's very convenient if we have some number line, because the variable is x, so I put x-axis, this is the number line, I put a 0 at a splitting point between negative numbers and positive, and here we can depict inequality x more than 5, strictly more. How we can do that? So we can choose or fix the value 5, and simply your x variable can intake any number, any real number from the range above 5. How to depict that? So many mathematicians use specific whole, right, or hollow point in order to exclude value 5, because in this case, when you can see the inequality strictly more, it's called strictly more than 5. That's what actually you need to keep in mind when reading this inequality. Strictly more than 5, so 5 is excluded. So this hollow point means your 5 is excluded. 5 is excluded. You don't include it, basically. But any value above is actually good and work for you. So instead of shading, many mathematicians use the following. They put a specific line with an arrow. So from here up to, or in direction of positive x-axis. So starting from 5 but not including that. So that's why what they do, they just simply exclude this point, and instead of words, they just depict a hollow point with the arrow to the right side. That simply means how you represent this on the number line. Alright, so let's get practice with x more or equal than 1. In this case, we have 1 somewhere here. Because 1 is included, you see, this is non-strict inequality. That means more or equal. So more or equal, that's what the sign means. It means we're starting from 1. Now we include, that's why it's basically the point tells you that we need to include your limiting number or your boundary, and straight to the right. So now I put a black arrow. That means we include boundary point 1 and above. Alright, how we can depict C? So for this reason I just put a separate number line. So I put 2, this point is included, so I can shade that, or instead of shading I can also depict with the arrow to the left. That means that represent x less or equal to. So what about strictly less than -1, the case? So simply we fix the point -1 and x value is less, strictly less. In this case, we just simply exclude the point and put an arrow to the left in the negative direction. That simply means that x is less than -1. Alright, so here's a simple rule. When you see some variable and the number, like in case A, you can read this x from left to right as x more than 5. So what if you want to say not starting from x, but starting from 5? What you can say that 5 is just less than x, simply. Okay, so probably this is almost the same as in balance. However, you need to take into account if you just consider scale, that's scale basically. If you consider scale, you set up x value here, while you set up 5 on the right plate, and the left plate is simply heavier, right? So obviously you want to have the balance in this case, like with equations. Here your scale will be unbalanced. X is heavier, that's why it's read, so you can read as x more. What if in the case you have x more equal than 5? More than 5 or equal to 5. So in this case, equal to 5. In this case, you might have some balance. So the balance might be, and it all be completed when x is equal to 5. When you take any x value that's more than 5, the balance will be broken simply. Alright, that's sort of how you can visualize using scale as we apply for equations. Alright, let's go next. And this is sort of inverse task or inverse problem. Write down the inequality used to describe a set of numbers. Alright, so we have from 0 to obviously infinity. In this case, 0 is not included, so you can write as x, your variable, can intake any values strictly more than 0. In that case, from -2, including the boundary number, and up to -infinity. How to convert it into the inequality? So you simply take x and say that is less or equal than -2. Let's go to the last one. So 100. 100 is included, and we go to positive direction. So in this case, x is any more equal than 100. Let's say you have how to depict double inequality. For example, when we have two numbers, a number line, and the line segment is just between them. For example, we might have 0 and we might have, let's say, 5. So we want to depict as whole point with a fill-in. So 5 is included, so the right boundary is included, the left boundary is excluded. So that's why we use hollow point and fill-in point. All right. So how to put it into inequality? So just simply say that we use double inequality. So double means you have two inequality signs. Double inequality. All right, how to work with that? You just simply take x. X might be any in between 0 and 5, but however, the left boundary is not included, and x is more than 0, but the right boundary is included. So that's why it's fill-in point. And you can convert into this sort of inequality. So it's written as double inequality. However, you can write it using the following notation. So you can write that x more than 0 and instead of and, you might use specific sign that which is called union. In union with, in combination with x less or equal than 5. So in total, you'll have actually the same as you have here. And union sign basically tells you that and or in combination with. In combination with. So x more than 0, strictly more, in combination with x less or equal than 5. That's how you can interpret that. All right, and now finally, I'll give you shortcuts how to solve efficiently any inequalities. In this case, we consider A. So actually, what you can do, you can, and actually the methods, you don't touch the inequality sign. So you always write as it was originally. So we consider A, and what we're gonna do, we just simply keep your inequality sign in that position, in the original position, and don't change. So never change the sign. But you can do the following. As with the plate example, you always keep transferring variables so that to collect variables in one side, but in this case, not of equation, but of inequality. So basically what do you have right now? So you have unbalanced the left hand side plate, so that's why it's heavier. Okay, it should go down, so while this should go up. So on the right side you have x minus 5. So our goal is to collect variables, so you take 3x and x and want to combine one side. So you again analyze strategically and several steps ahead. Obviously, if it transfers 3x to the right side, it will change sign into the negative, and it will be inconvenient. In this case, you leave the greatest variable with the greatest coefficient on the side so that it will be positive. And when you transfer x to the left side, it still be positive, because the result, what you have on the plate, on the left hand side plate, you'll have the following. So 2 plates, again, keep inequality sign as it was originally, so you just simply rewrite your sign. And now what happens? So 3x becomes combined with x. So because you transfer x to the left side of an equality, you do the same as you did with equations. So you notice that you combine x's. Now it's time to combine all the numbers. So you have -5, and if you transfer 2, so simply you'll have -2 as well. So you'll get -5 and -2. In order to finally solve, you simplify. So first, basically, the transfer in order to collect variables or repeating unknown, like mostly you'll have x's, just only one variable, but it might be repeated in this case, and collect numbers. So I've collected variables in the left hand side or on the left plate, and here I collect numbers on the right plate. Keep in mind that you still keep your inequality sign as it was originally. So second step, what to do? Just to simplify. So now you haven't deal with similar terms or like terms. So 3x minus x will give you 2x. And here you'll have -5 minus 2 minus 7. So that's almost the solution, except for right now we need to find out x. So now attention. We tend to have 2x to be positive, and actually it is right now. So 2x is positive. Now you can divide, as with the equation, you can divide both sides by coefficient, by 2. In this case, you'll have the following. So 3, just try to leave x more or some equal to more something. And in this case, we need to divide. So divide by 2. If it's going to be another coefficient like 3x, you need to divide by 3. If the coefficient is 1 over 3, so instead of division, you multiply by 3. So I think we'll have plenty of examples, so don't worry. Just right now, we need to run through a simple example or a simple problem in order to get to more complicated. All right, so we have the following. X still here is more than -7 over 2, that means 3.5. So 3.5 with negative sign residing on the right plate. So what to do next? Just simply, if you don't ask to do like anything like graph inequality, like put on the number line, just leave your answer as it is. So your solution is already is ready. So your solution is ready. It's done. So, but if you want to depict it, again, just remember about number line, fix the point, -3.5 is excluded, so input a corresponding arrow with the whole point. It means signifying that you don't include -3.5. So where it goes to positive infinity. All right, so we've got how to cope that. Let's consider maybe other examples. For example, let's say here, so 2x minus 3 less than 5x minus 7. I just rewrite somewhere below, and we try to go through all the steps that we have before, but maybe a bit quicker. So I just write it separately. 2x minus 3, we consider b right now, less than 5x minus 7. All right, so what to do now? It is simply want to transfer. The first step is transfer. So you keep an equality sign as it is, and you take 2x and transfer to the right, while taking -7 transfer to the left. What exactly you'll get? You'll get 7 minus 3, because swap the sign, and 5x with swapping sign minus 2x. The next step is to simplify. So you'll get 7 minus 3, you'll get 4, and here you'll get 3x. So because you have positive coefficient before x, that's good. That's the same we intended to have in equations. The same logic here in inequalities. So we divide by 3 both parts, so we'll get x more if you read from the right to the left, so x is more than 4 over 3. But actually, you can also read in a bit different manner, or you can read as x more than 4 over 3. So what you did, you actually swap inequality sign, because if you read from the right to the left, so actually x is, you compare with the number, so that's why x is more than 4 over 3. So that's why you need to write the same. So actually your inequality is not supposed to be changed. So many students write like this. So x, if they swap, they swap the variables and the number, and actually that will cause mistake, because now if you read correctly, what is actually written here, you'll read like the following: x is less than 4 over 3, but before it was more, so you need to put the right word. So x is more than 4 over 3. So that's why your meaning should be changed. In this case, it has been changed, so it's not correct. The correct answer is here. So you just rewrite as if your meaning is still the same. So that's why x is more than 4 over 3. All right? I hope you got it. So that's the answer. Next one, C. I'll do it quick here. So what I need to do, I need to collect variables in one side. Let's assume for some students might prefer, and they might not go several steps ahead, so they decide to transfer this x to the left side. Okay, let's see that's how it works. So we consider C, and what if you just transfer negative 2x and x to the left side? And probably you transfer 5 to the right side. So 5 you don't have anymore, so you just have more equal. Then you transfer 5 to the right side, you'll get minus 5 plus 4. What to do in this case? Of course, it's not good because you have negative number, but however, finally you can do that. So you'll get negative 3x more equal than minus 1. So what to do next? So many people decide to divide by negative 3 and leave the sign unchanged. And that will cause the problem, because you'll get finally 1 over 3. So the right number, but however, it's incorrect because of this sign. So this incorrect. Because there is specific rule, when you divide by negative number, you need to swap the sign. However, I don't recommend to memorize that. And in order to do it correctly, I'll do the following. So instead of dividing by 3, I just simply want to say that we can transfer negative 3x to the right side while negative 1 to the left side. We still keep the inequality sign the same, so we'll get 1 because of changing the sign to the opposite, and 3x also becomes positive. In this case, it's still everything correct. So you just simply need to divide by 3. 3 is positive, so you keep the sign the same. So that's why what you need to do, you just simply need to divide both parts by 3. So you'll get 1 over 3, keep the sign as it was originally, as you notice, and never change the sign on its opposite. So, and instead of 3x, I'll get just x here, because 3 was cancelled. So in this case, I see that x is less or equal, so you can write x is less or equal than or to 1 over 3. So that's why when you swap them, you start from x, it should be still less or equal. So those words don't need to change. So that's why x less or equal than 1 over 3. And this is correct. So this now correctly done. Okay, so, and this is solution for C. So C has been completed also. Okay, so let's erase a bit more space. Have more space here. So, and we finalize the top one. And the rest part I just solve quickly. And you try, maybe you can pause the video and then compare with answers that you have with mine. So I do D. I just transfers negative 3x to the right side. I'll get 3x minus x. This is more or equal to what we have on the left side. 7 minus 5 is 2. So I have 2x more equal than 2. And finally, I'll have x more than 1. So I understand that this x more than 1, so now I can swap and say that or x more equal than 1. I don't change the words meaning, but I just swap inequality. So you see, only in the ends I can swap that. But actually you can leave as it is. So it's actually also correct. If you even just can demonstrate on the number line, both you and examiner will consider it correctly and in the right way if they even just visualize that. So we have x more or equal than 1, so we put 1, it's included, so you put a shading or just use arrow notation from 1 to the right side. Perfect. Let's go to E. Let's do it quick. So we have 3x minus 2 equals, okay, so many variables, many repeating, the variable is the single one, but it's repeating. So we do the same as we did with equations. So I'll just expand brackets and then simplify and try to collect all the variables in one side. So obviously I'm thinking ahead and just combine 7x and subtract 3x. So we'll get 4x here, and then negative 2 plus 2, they will be cancelled, so you can cancel immediately them. Or just work how they should cancel finally. So 4x less than 0, so in this case it's positive coefficient, so I simply divide by 4 and I'll get x less than 0. Or you swap that and write this, x less than 0. That's okay. That's E. And the last one, F. I'll try to do it mentally. I expand in 2x and minus x, so I transfer minus x to the right side, so I'll get 3x here. So I'll have 10 here, and minus 1, I'll have 9. 9 transferred to the left side, in combination with 1, I'll get negative 8. So, and finally we have minus 3, so plus 3. And finally I'll get the following, so 3x and negative 5. That's the final solution, x less or equal negative 5 over 3. So if you want the same level, you just need to do mostly mentally. That for those who feel free and very confident with just simple rule that we applied before. So that's the answer for F. Perfect. We've done everything, and probably what we can do, actually we finalized, but let me see, do we have any application? I think that's pretty enough. Yeah, that's pretty enough. Everything rest will be in revision. So hope you enjoy, guys. Just keep in mind that simply we need to adhere to the steps mentioned here. Actually they erased, but the steps are pretty the same as for equations. So just first it's about transferring. You every time keep the sign the same. Try to collect variables so that coefficient becomes positive just right before them. In order finally you can divide or multiply. So I didn't consider fractional inequality, but this is a separate topic and it's better to create and make another video for this. So I hope you enjoy. Don't forget to subscribe. Just share this video to anyone interested in math, to third parties, and actually give some comments. It was clear or not. There's maybe some clarification required. So it will be helpful for me and for you guys. So Daniel Dallas was there. Hope you enjoy and bye.